Well, Rovers, in this episode, I'll be building this beautifully curved segmented beam for our bulkhead, and I think I found an electrical solution for our power requirements. The Rover 650, a design based on my single-handed ocean voyages. She's small, light, but easy to build and strong enough to cross any ocean. My name's Alan Mulholland, and this is the Wave Rover story. Now, if you've been watching the series for a while, you know how concerned I am about losing time. Why? Because I'm on this incredibly tight schedule to get Wave Rover launched this summer, and that's only a few months away. I cannot afford any downtime, any delays. And delays about power have been a big concern of mine. We have lost, or several people on the island here lost, up to 2 weeks of electricity when Hurricane Fiona came through. Now, don't get me wrong, I enjoy living in the country. It's a great place to live, but with that comes some, well, dodgy infrastructure that can really slow one down when they're on a tight schedule. And I think I may have found a very, very good solution for my power needs. So this is the BLUETTI 200Max power station. So let me break this down into something that is understandable to someone like me. This is essentially a battery that can take power from a number of different sources, whether you charge it from the house electrics, or more likely in my case from a solar panel, and you charge it up, and then that stored energy can then be converted into regular AC power. So typically a battery stores DC power at 12 volts. Well, it takes that 12 volts and it turns it into 120 volts, and that 120 volts is what they call a pure sine wave. So a lot of older technology, you can't run a computer or any finer electronics off them because the power isn't stable enough. But this is 100% stable, and you can operate just about any power source off, right up to 2,000 watts. Now, what can you run with 2,000 watts? Well, 2,000 watts would include my table saw, it would include my router, my circular saw, all the tools that I'm using. Obviously, I'm one person, I'm not running all those tools at the same time. Now, those tools have a huge surge when they start, and this can handle a surge up to, I believe it's 4,500 watts, and then maintain the 2,000 watts through operation. So that is what my main concern about this is. Can it handle my production on Wave Rover when the lights go out? And I'm pretty sure it's going to handle it. And we're going to be checking that over the next few videos. I'm going to pretend like we have a power outage. I'm going to hook everything into this and just see how it performs. Now, there is this alternate thing that's ticking over in my head. Would it be appropriate to take one of these on Wave Rover? And why would I want to? Well, the reason is I've been looking into solar for the last few weeks, trying to figure out what I need, and it's a series of components that you buy and you stick together. Whereas with this is plug and play. I just need to hook this into my what would you call it? My power panel, and then hook all my electrics into that. This powers the panel with the added bonus that it has a pure sine wave inverter. That's the piece of equipment that allows me to operate my regular household tools, my drills, a refrigerator if I want to go that direction. So plug and play, that is nice and simple. One component, one wire coming in from my solar panel, well, two wires coming in from my solar panel, and then a couple of wires going to my power panel. That is maybe one of the things I'll be thinking of down the road. But let me just talk about what this can actually do at the home level. This has a battery with a capacity of 2,048 watt hours. Now I know many of you are sailboat people and you want to know what is that in amp hours. The battery is a lithium iron phosphate battery that has a capacity of 170 amp hours. Now this unit's also capable of expansion, which is something I'm going to look into. If you add two of their B230 batteries, that'll increase the power to 6,144 watts or 512 amp hours. Or you can add up to two B300 batteries. Now those sound interesting, and that'll increase the capacity up to 8,192 watts, which is the equivalent of 682 amp hours. So how about recharging? Well, you can charge this beast with up to 900 watts of solar input and or 400 watts of the wall power, the wall unit that comes with it. Now you can combine those together and that'll give you 1,300 watts of charging ability. So that's only going to take 2 hours or less to charge this unit. 30 amp, 125 volt receptacle. We've got the 110 receptacles. We've got 4 of them, and they're actually set up for 20 amp plugs, which is great. Then it has, this is the DC side right here. So if you're running DC, you don't actually need the inverter. It just takes the power directly from the battery. We've got a couple of USB ports, couple more. I'm going to have to read up on this and find out what the difference between these two is. One is a heavy duty one is a little bit lighter. And this is called a USB-C. Again, I'm going to have to figure that out. That's 100 watts, 12 volt, 10 amp. And this says 12 volt, 30 amp. And up here, 12 volt, 10 amp, the cigarette lighter. And then over on this side are all my connections. I don't want to confuse anybody anymore, so I'm going to have to read up on this and figure this out. But this is where the charging would take place from our hydro supplier, our electrical supplier, or where the input from the solar panels would go. I have a couple items that I've never actually used before, and these are wireless charging stations, 2 of them. At 15 watts each. So as far as I understand, something that can handle it like a smartphone or maybe even a tablet, you can charge directly on this. Not sure exactly, but I'll find out when I start using this. I think that's all I have to say about this. I'm looking forward to using it and testing it out a little bit. But right now, I have to get back to the boat shed. I've got a boat to build, and I'm building a beautiful segmented beam. Time to crack on. Well, time to crack on with today's project, which will be a segmented beam on this very important bulkhead. This is the bulkhead that forms the transition between the big camber in the aft end of the cabin to the forward camber, which is different. Now, this segmented beam doesn't need to be difficult, but it's something that I'll be seeing every day, so I want it to be kind of neat and tidy. The first thing we're going to do is, well, let me just tell you what's happened off camera. This piece right here, you would have seen me work that in the last video. I took the belt sander to it and made a pretty nice curve that's the same as the plywood here. I also cut 45 degrees, just a straight 45 degree. You can use either your skill saw for that or the chop saw. And I did the same on the other end over here, but I did it opposite. That's just the way I think. I can see that there would be no real difference if you ran this 45 the other way. Now, this piece right here, that is as good a joint as you want. There's quite a height difference right here. That's fine, because once this is all glued up, then I'll be taking the power plane to it and I'll be leveling everything out and making it look good. All right, first thing I want to do is show you how I go about making that joint, and we'll do this one right here. So job one on this is to figure out what angle to cut this 2x4 on. And obviously we'll be doing a 45, but we also need to know this angle. It's a compound angle we're doing. So what you need is a bevel or something like a bevel, and line it up with the angle of this piece. Okay, so there we go. Now I can make this anywhere I want on here. I've got plenty of length in this 2x4, so I'm just going to study it, make sure that I don't have any problems, and I'll just make it right there. So I've marked the line. Now I've done this enough times to know that you've got to do this next step, and that is you've got to make some indication on here which way the 45 goes. So I know that just looking at that, our 45 has to go that angle. So now we can, our saw looks like this. So if it were cutting like that on that angle, it would be, let's see, angled that way, it's the right way. So if I start my saw and run like this, I'll end up with the right cut. I don't have to mark that 45 because the saw is set to 45 degrees. So I've set my saw to 45 degrees. Now there's something I want to bring your attention to, and that is these little index lines on the leading edge of the saw table. Now normally I use this one that's marked 0 degrees, and if you use this index line rather than trying to stare at the blade, you're going to make a better cut 99 times out of 100. But when you do a beveled cut, that's when the saw is angled like this, you need to use the 45 degree line, which is a good distance to the left of the 0 degree. All right, and now the other important thing is the saw blade lines up on the other side of this line. So essentially, if you line your index line up with your pencil line, the saw blade will be to the right of the cut. All right, enough talk. Let's get this cut made. Hearing protection on. The other important thing is you have to lift the saw guard, because if you don't, it gets caught, at least on my saw. Okay, that looks pretty good. Now let's do a test fit. Okay, so that's what we're looking at. This is the test fit. And why is it not totally tight? Well, part of the reason is because we have to take out this amount of wood right here so it sits flat. So that's the gusset. So we'll be removing wood. We'll be marking for that right now, and then I'll remove that with the skill saw again. So I've got the saw set back to 90 degrees. I've set the depth of the blade to 3/8 of an inch, which is 9 millimeters, to accommodate the depth of the gusset. And now I'm just going to make a bunch of relief cuts along here, and then we'll end up chiseling it out. Good time to check the depth. Yep, that's 3/8 of an inch, so we're good to go. So that's what it looks like after you've made the cuts. The closer you make these cuts, the easier your life's going to be. That's pretty good. That's enough cuts on that one. How long did it take? Oh, probably not more than about 2 minutes. So to remove this waste, You could use a chisel right off the bat, but I prefer to use my framing hammer. I'll just show you that. And the framing hammer, you just use the claws to knock these. And let's see, get this side. Okay, at this point, I switch over to the chisel. Now, I know there's a variety of ways you can do this. You could set up your router and go at it, but I actually like the peace and silence of using hand tools whenever possible. Okay, so this is what it looks like after the chiseling out. That's good. We'll do a test fit, and if we need to take more off, we'll take more off. We can actually hit it with a belt sander. Now, some of you are probably saying, that's not the way I would do it, or, you know, why don't you use this tool or that tool? The thing is, I don't have an endless supply of tools. I use very, very basic tools, and if you think, you know, I've got everything, check out the other sailing channels. They've got massive tools, you know, huge bandsaws, thickness planers. I'm just using really the very basic of what just about any home handyman has to work with, and there's a good reason for that. This boat, part of the Rover philosophy was that it should be attainable by any backyard builder, you know, with pretty much none to just rudimentary tool skills and tools. So now let's crack on with the test fit. Okay, that is pretty good. By the time it's clamped down, that's a pretty nice joint. And how are we? Over here, we are sitting, yeah, we're sitting really well. I don't know how well you can see that, but yeah, I have a little gap along here. Let's back up a bit, a little gap along here, and then it gets tight over. Oh no, that's because this, let me see if I can fix that. Oh yeah, the gap is even throughout when it's tight in place. All right, we are happy with that. We can carry on. Now with these three pieces locked in place, all I need to do, or the next step, is to scribe a line along the bottom. And you guessed it, now we're going to unclamp everything, turn them over, and cut off that line. Okay, so I'm going to cut this curve, and a lot of you would probably automatically go for the saber saw or the jigsaw, which is a great tool for this, but I find that the jigsaw doesn't cut plumb. You know, sometimes it does, sometimes it bends one way or another. So that's why on these curves that aren't very great, you can get by with using a circular saw, which I'll do right now. Okay, time for a test fit. Okay, so that's what we're looking at. That's a nice curve. You know, reasonably nice. It's not perfect, but that's fine. Once we get this locked in place and secured, we'll just take the belt sander to it and smooth out any rough edges. So at this point, The next step is I want to reduce the other side, this side right here, to 2.5 inches consistently right along the whole beam, and then we'll be ready to start gluing it up. 2.5 inches, that's my measurement. I'm basing that on, I'll be running longitudinal stringers into this to support the cabin top, and they are going to be about 1.75 inches. So that gives me still 3/4 inch of wood underneath the stringer, which is plenty when you consider it's all going to be epoxied in place. All right, time to carry on with scribing the next line. I've actually discovered that I'll have to make this 2.25 inches, which is the minimum depth I have here, and that's still fine. That still leaves 1/2 inch of wood under the longitudinal stringers. So to do this, I'm just going to use my speed square, hold my pencil at 2.25, and just glide along. You could just use a block of wood for this as well. So now I have a nice line that I can cut to, and I'm going to use the jigsaw or the saber saw to make this cut. I will leave the line because I'll be hitting it with a belt sander or some sanding device after to ferret out. Well, we're almost there. We're just going to do a little bit of sanding on the inside edge. I'm not worrying about the outside edge at this point because after the glue up and there'll be glue squeeze out, then we'll hit that with just a belt sander. It won't need much, I can guarantee you that. We're looking pretty good. All right, a little bit of sanding. So you could use just about anything to sand this out. You know, a block of wood with a dowel and just work back and forth. Start with something like a 60 grit and then move on to about an 80 or 100 and you'll be just fine. You could use your palm sander, but any electric tool you use, you've got to be really careful because they can bite really fast. Now this is a polisher sander that I bought back in 1993. That's the last century for some of you. Now, the reason I bought it was the first boat I was building, I had a mahogany hatch, and the inside of that mahogany hatch, you know, I glued it up with segments, and then it had to be sanded. And this, because of the cushion that you feel right there, this is the ideal power tool for it. I'm using it because I had it, or I have it. If I didn't have it, I would be using some sandpaper. Oh, the other thing, if you do have one of these, or if you run out and buy one, they will come in handy when I'm ferrying the boat as well. You've got to be very, very light. I will be using no more than the weight of the tool to do the sanding. If I press in, it'll just make a great big divot. So, you know, we've taken a fair bit of time now to create these segments. We don't want to have to start all over again. And that half is now done. I can see any saw cuts, and that's what I'm removing. The camera probably can't. So you just carry on with that. Wow, it's absolutely like springtime today. But as I just saw, we're in for a pile of snow tomorrow night. It's funny to think, where will Wave Rover be this time next year? She should be somewhere in the Caribbean. Well, time to get back to this ring frame. It's not a ring frame. Time to get back to this segmented beam. So now by clamping it in place, I can just roll it over and then we'll get screws set, nice stainless steel screws set, and that'll hold it in position. Then we'll unscrew it, glue it, and screw it back up again. Nicely countersunk. Well, now we can take it into the nice warm gluing room and glue it up. Well, now that it's been unclamped and moved out here, we can work on it. There's just a few little things like right here where there's that slight height difference, really not much, maybe a 1/16 of an inch, but I'm just going to run the power plane over that, and then we'll do a nice round over on the inside edge here, and this will be done. Very happy with how it's turned out so far. Well, there we have it. The finished product. That's not bad. That's not bad at all. For a simple carpenter and sailor like myself to end up with this segmented beam, it wasn't difficult. It wasn't difficult to do at all. And I hope that others will be able to follow and maybe improve the technique. But that's not all I did this week. So I also built a segmented beam for the aft bulkhead. Now this one looks very angular on the top, and that's because I haven't reduced the top to its finished size yet. I can't do that accurately until the next bulkhead is in. I also got this beautiful beam on the watertight bulkhead. Now in the next episode, I should be able to get all the bulkheads installed permanently, and if Mrs. Rover lets me, I'm going to do a little bit of scarfing inside our warm house. So until next time, Rovers, thanks for watching. I'd like to take a moment to honor the Wave Rover benefactors. So what is a benefactor? Well, these folks have made a contribution of $100 US or more to the project, and their names will be affixed to a bulkhead inside Wave Rover and will be traveling with me on our circumnavigation. Now, these donations truly are much appreciated. Well, the Wave Rover patrons, with their pledges of support, really do make the creation of these videos possible. Now, if you'd like to know more about Wave Rover's patron page and benefactors bulkhead, I have links to both those pages in the video description. Now, another way to help Wave Rover, and it doesn't cost you a dime, is by sharing our content on your social media. So now, as always, Rovers, thanks for watching. Give us one more. Brilliant.